Okay, so we are moving right along in our functions topic. We are at lesson 6, function notation, and I'm going to break down the U-tries in this video. So if you need some help or want to check your work, please be sure to watch this and hopefully you will get some clarification. In this problem, we are given 3 functions, f of x, g of x, and h of x. And for 1 through 6, we're using one of them or more than one of them within. We just have to pay attention to which one we're using. So in number 1, we see f of -6. So that's telling us we want to use our f of x function. And essentially what it's saying is wherever we see an x, we want to take that x out and substitute in -6, okay? So that's going to look like I'm going to put the equals right next to f of -6. The 4 is going to stay. That's going to become -6. And remember, that's saying 4 times x. So when I plug in that -6, I put parentheses around it to make sure we're communicating 4 times -6. And then we bring down that plus 7. From there, we're just doing order of operations, your PEMDAS, and you're going to simplify that down to a singular number. So 4 times -6, we have -24. Plus 7, that gives us -17. So what this is saying is that f of -6 is equal to -17. So we're saying the input to this function is -6, the x value. The output, f of x, the y value is -17. So that would be the point, -6, -17. Okay? For number 2, we are evaluating g of 2. Whoopsie. So we want to use our g function here, okay? And basically, similar to number 1, but wherever we see an x in this, which we see it in 2 places, we're going to take that x out and substitute in 2. So I'm going to, once again, put my equal right there. I have a -3. I'm taking out this x, that's the only thing that's changing. I'm going to put parentheses around it and plug 2 in. We're still squaring that 2, plus 5, and I'm going to put x, that x in a box, and I'm going to substitute in +2. After we substitute in our input, we're good to go to simplify that right-hand side using order of operations to find what our output is, which is our y value. So once again, using PEMDAS, please remember that we are just squaring the 2 in this case. So exponents come first. So we want to take care of 2 squared first. And that's going to give us 4. Common mistake is a lot of people jump right to multiplying -3 times 2. But remember, exponents come first. That -3 is not in parentheses with that 2. Okay? Now we have multiplication, and we'll work from left to right. -3 times 4 is -12. 5 times 2 is 10. And now we're going to add those 2 things, and we get -2. So that's saying that 2 is our input, our x value. And when you plug 2 into the g of x function, our output is -2. So we have the ordered pair 2, comma, -2. And I'm going to just write g of 2 equals -2. So it will depend, reminder, how your teacher is asking for your answer. Okay, number 3, we are using h. It says h of 18. So I'm going to go up here and highlight the h function, h of x. It says take x and divide it by 6. So wherever we see that x, we're going to take that out, swap that out. And in this case, we're going to plug 18 in. So we're doing 18 divided by 6. Really simple, one step there. That's going to leave us with 3. So h of 18 is equal to +3. What that says is that our input is 18. When we plug 18 into our h of x function, our output, our y value, is +3. Awesome. Number 4 is where it gets a little bit, I think, more fun, but we have 2 functions here. We have to evaluate them separately. So a couple people get confused when they see, okay, I have f of negative 3 and f of 10. What do you want me to do with that? And I want you to think, okay, let's look at just this. Let's evaluate just f of negative 3. So going to my yellow function, f of x, wherever I see an x, I'm going to swap in negative 3. Okay. And I'm going to do PEMDAS to get that down to a single number. And we get negative 5. So f of negative 3 is equal to negative 5. So I'm going to go here, and I'm going to actually take f of negative 3 right here that I'm kind of putting in a thicker blue box, and I'm going to say, okay, I can pull that out. I know that is equal to negative 5. So I'm going to substitute negative 5 in its place. Okay. I transfer over that minus sign that's in between those two functions, or the two function notations, right? It's just a minus sign. Now I'm going to evaluate f of 10. So I'm still using the f function. I'm going back to f of x, and wherever I see an x, I'm now plugging in 10. I'm going to do my order of operations, and we get 47. So once again, I'm going back to this box, making it thicker. I can now take f of 10 out, and in place of f of 10, I can put 47. If it was negative 47, I'd put negative 47. And now all we're doing is we're just simplifying this. We're saying, okay, what's negative 5 minus 47? And that answer is negative 52. So what happens when you subtract you do f of negative 3 minus f of 10 is we'll get negative 52. So that should be our final answer then. So we found the output for f of negative 3, the output for f of 10, and we subtracted them because that's what it told us to do right there. Okay? For number 5, it's asking for g of negative 1. That's the function notation. And then it's saying take what you get for g of negative 1 and add 8. So it's saying here, evaluate this, and whatever you get, you're just going to do plus 8. You are not plugging that 8 into any of your functions because it's just a regular plus 8. It doesn't say f of 8, g of 8, h of 8, right? So it's saying we're going to evaluate g of negative 1, and then we're going to take that output, and we want to tack on plus 8 to it. Okay. And so here we see, okay, negative 1 squared is 1. Remember, we're squaring first in that case. Negative 3 times 1 is negative 3. 5 times negative 1 is negative 5. And so g of negative 1 is equal to negative 8. So now what we're doing is we're saying, okay, I'm going to substitute in what g of negative 1 is equal to, which is negative 8, and then I'm going to do plus 8. I'm just carrying that thing over, and I get 0 as my answer. So when I evaluate g of negative 1, I get the output of negative 8, and then I add 8 to it, we get 0. Awesome. Okay, our last one. This looks a little bit different than what we've seen so far. So there's h of 12, which I think is important to notice, that h of 12 right there. But how it's being connected to negative 5 is it's being multiplied by negative 5. And how I know that is if you look between negative 5 and h of 12 right there, there is no operation. There's no plus or minus sign. So when you see a number and a variable or the absolute value or something right back to back, parentheses, that tells us that we are multiplying. So what we're really going to do here is exactly what we did in 4 and 5. We're going to evaluate h of 12, and then we're going to substitute that in and multiply it by -5. So h of 12, and I rewrote the h function right above here, is saying, all right, take out that letter x and substitute 12 in. So we're going to have 12 divided by 6, which is going to give us +2. Okay, so now we're going to bop back up, and we have -5, and I'm substituting in place of this box, I'm substituting in 2. And just like when we evaluated expressions, when we substituted a number in for a variable or in to represent something, we always put that number in parentheses when another number is glued in front. And that tells us, okay, we want to multiply these. So now we see -5 times 2 is -10. So those are our 6 practice problems for function notation. If you have any questions, hopefully they got answered in this video. I can't wait to continue our functions topic with you. Keep up the great work, and I can't wait to see where you go next.